Hello, welcome to our presentation. My name is Qiusheng Wu. I'm from the University of Tennessee. My co-presenter is Tyler Erickson from Google.
Hello, I'm Tyler Erickson, a developer advocate working on the Earth Engine project at Google.
In this presentation, we are going to talk about how Jupyter and geemap enable interactive mapping and analysis of large-scale geospatial datasets. The slides of our presentation can be accessed through the link here at the bottom, gshub.org/JupyterCon. Here is the outline of our presentation. First, I will let Tyler talk about the motivation and need for the geemap package, and then I will introduce geemap and how to install and get started with the package. And then I will demonstrate some of the API documentation and video tutorials and key features of the package. Lastly, I will show you some additional resources and how you can contribute to geemap. On the right here shows you an animation of surface water dynamics using the Landsat satellite data for the past few decades. And this is something you can easily create using the geemap package without writing any line of code. If you want, you can try out the web app here by clicking the link, and then you can navigate to any location of your interest and draw a rectangle, and then you will be able to create an animation like this for any location and to be used in social media or on your website. You can also check out the notebook example to see the source code behind how this app was created. So next, I will let Tyler talk about the motivation of the geemap package.
And I'm going to give a little motivation for the GEE package and why I think that it's so important. To understand the need for GEE map, you first need to understand what Earth Engine is. Earth Engine is Google's cloud platform for earth science data analysis. It runs in Google's cloud infrastructure and gives you a browser-based access to remote sensing data, climate and weather data, DEM files, etc. The homepage is at earthengine.google.com, and you can also find the developer docs for the API at developers.google.com Earth Engine. What's important to also understand is that Earth Engine and Google Earth are two very different products, even though they work together. Google Earth is what most people are familiar with. It's the 3D globe that allows you to zoom to anywhere in the world, zoom into your own house, etc., but it's mostly a visualization tool. Earth Engine, on the other hand, is a geospatial analysis tool. It's used to generate data. Earth Engine is composed of two important parts: a very large data catalog of earth science data and a computational platform that allows you to apply algorithms to that earth science data to get results that you need. This functionality is available through a variety of APIs, including Python, JavaScript, and a REST API. The Earth Engine data catalog is extensive. It contains currently over 30 petabytes of data, and we're adding about 1 petabyte of new data every month to it. The largest data sets in the catalog are from satellite imagery, from the Landsat and Sentinel programs, but we also have vector data in here, terrain and land cover, weather and climate data. A common workflow in Earth Engine is to start with a large collection of images, develop an algorithm that can be mapped over all of the images, apply that algorithm, and then reduce all the resulting images to produce a single image or a table or some other output. One way you can think about Earth Engine conceptually is think of it as a large funnel that actually takes lots of input data from satellite data, weather data, etc., and then it filters it down, reduces it to something that's quite a bit smaller, like a chart, a map tile, a table, etc. And this filter will have a series of knobs that a user might want to control, like what location, what time, etc. But the key concept of this is that there's a large reduction of data. And we even have this concept encapsulated in the EE reducer objects within Earth Engine, which at this point there are about 50 different ways to reduce collections of objects in Earth Engine down, as you can see over here on the API reference docs on the right. So for example, for EE reducer percentile, you can specify a collection and then a list of percentiles like 5th percent, 25th percent, 50th percent, and then it will basically reduce all of the images in that collection. But another important point to keep track of is that there are many knobs potentially for these algorithms that are being run inside of Earth Engine. And you need a good way for your user actually to specify the values for that knob so you can control how the data is being reduced. Now, the Earth Engine team has been maintaining a browser-based development environment that we call the code editor or playground since 2012. And it does a lot of things that you would want to do when you're working with earth science data. So it has a place to code things up, a code editor window, has a way to manage assets that you're uploading or referring to them. There's a way to save scripts. There's a place to get output, whether it's a console output like a chart, or you can actually overlay layers on a map, and you can authenticate, things like that. All of this is contained within the code editor. So it's really useful for actually teaching Earth Engine. We use it to teach classes and allow people to learn the concepts of it. However, in order to use the code editor, you need to code against the JavaScript API. And that can be a bit frustrating for Python programmers. So, can Jupyter help in this regard? Well, I think so. Back in 2014 at the SciPy conference, I presented a prototype widget for an IPython notebook at the time, this is before Jupyter, that would allow users to refer to Earth Engine algorithms and display the resulting tiles on an interactive map. And it worked, but it was a little bit hard a lot of code was required in order to do this, and didn't feel that it was ready to be maintained at that time. Skip forward to JupyterCon 2018, presented some work of hooking up the Jupyter widgets, in particular ipyleaflet, bqplot, to the Earth Engine Python API. And that allows you to do some more complex interactions because of the two-day directional interactivity of the widgets. So you could actually select a location on a map, get back time series data, select a location on time series, get back map data. And so this concept, I knew that it could work, but there's still a lot of code that needs to be done, a lot of configuration in order to get the two parts to be connected together, Jupyter and Earth Engine. But that's where a geemap comes along. The geemap package simplifies a lot of the interactions that a typical Earth Science user would want to set up when they're working in a Jupyter environment with Earth Engine. So with that, let's go into a deeper dive of what geemap provides.
So next, let's get into the package. And so the package is open source, hosted on GitHub. You're welcome to check out the link in here. Essentially, it is a Python package for interactive mapping with Google Earth Engine and also ipyleaflet and ipywidgets. So it's basically built upon the Jupyter widget system. And if you see from here, on the right here, I list some key dependencies. So the first one here is Earth Engine API. So this is the Python API is for doing computation. ipyleaflet is the plotting backend, how we can visualize Earth Engine data interactively. I also use Folium. So Folium is another plotting backend. And the reason I use this one, because the geemap package is designed to run on the Jupyter-based environment. But for Collect currently does not support ipyleaflet. So that's why I use the Folium. And also the ipywidget. So this is also very powerful. We use it to create all kind of, for example, drop-down lists to accept user input, also buttons and others. So it's how we use this one to interact with users and to provide output back to the users. We also use the bqplot. So the bqplot is used for doing plotting. So sometimes you need to see the plot time series. You can use this one. And the last one here is Voilà. So Voilà is how we turn a Jupyter notebook into a standalone web application. So then you can deploy this one to the internet, and people without coding skills or without Earth Engine account can also visualize your Earth Engine products. And so since it's a Python package, we provide a couple of ways for you to install the package. You can install using pip, or you can install using Conda or Mamba. You can also install directly from GitHub. And I also provide way here for you how to update the package. And I also provide a series of tutorials. You can watch the tutorial if you want to install the package. We also provide a Docker image. So this is provided by my co-presenter, Tyler Erickson. So you are welcome to check out the URL here and to look for the detailed instruction how to use geemap in Docker. So here I provide two simple examples for you to get started. If you want to use Google Colab, you can follow my example here on the left. If you want to use in Jupyter, your local Jupyter or your Jupyter server, you can see the example here from the right. So it's actually very simple. You just import the libraries and then add the Earth engine data, and then you display the Earth engine data. So simple and straightforward. If you use Google Colab, pay attention that we need to install geemap every time when you launch a Colab section, because the package is not installed by default by Colab. And also, you need to use the volume plotting backend, because ipyleaflet is not supported on Google Colab yet. And so this is relatively limited functionality. You can add the data to the map, and then you can visualize the data. If you want to fully utilize the interactive functionality of the package, then I highly recommend you use the ipyleaflet on the Jupyter Notebook environment or Jupyter Lab. So the differences between these two is that ipyleaflet enables bidirectional communication. So for example, if the user click a mouse on the map, and then you can use ipyleaflet to extract the coordinates, and then you can fully use the coordinates to extract data from the Earth engine datasets. But if you use volume, you cannot. Once the map is created, it's kind of static. You can zoom in, you can zoom out, but you cannot really accept user input. So I want you to be aware the differences between the two. On the left side here, I also provide a notebook example. You can click the link and do open in Colab. You can also have a video here shows you how to use a geemap in Google Colab. I also have a short paper that describing the geemap package. It's published in the Journal of Open Source Software. You're welcome to check out the paper if you're interested in learning more about the package. Next, I would like to introduce some API documentation. So here is the link at the bottom here. Provide the link to the documentation, and you can look at some of the examples I provided, and also tutorials. And also what I would like to point out is the API reference. So one thing that's nice about this is that you can look at the source code behind each function. So if you're interested in learning more what's behind each function, you just go to the website and then you click the function, and then you will be able to show you the source code. So this might be a good way if you want to contribute to this package. You can look at some of the source code behind. Next, I would like to introduce you to some of the tutorials that I have developed for this package. So if you go to my YouTube channel, I have a playlist for Google Earth Engine Python tutorials. So far I have developed 37 videos, and you can see here the total length is 9 hours. So due to the time limit, I don't have time to get into the details every video, but you're welcome to check out the YouTube channel and to learn more about how to use the geemap Python package. Here is a list of all the tutorials. So if here shows you 20, and the other one here has 16. So in total of 36 tutorials. And so for each tutorial, I provide the full-length video. Usually it's 10 to 20 minutes. I also provide a GIF animation. So if you don't have time to watch the full-length video, you can watch the animation. So just to get the highlights of the video. I also provide a Jupyter Notebook example, so you can reproduce exactly what I did in that tutorial. So you're welcome to check out all these resources to learn more about the package. So lastly, I would like to demonstrate some of the key features of the package. First, if you learn the Google Earth Engine, most likely you probably use JavaScript to get started. So in the geemap package, I provide some function for you to easily convert JavaScript examples to Jupyter Notebook and Python. So if you see from the video here, very simple. Just copy the source code and paste, and then hit run. You will be able to convert this one directly to Python, and then to display the result in here in Jupyter Notebook. If you already have a bunch of JavaScript on your computer, you can also use some functions in the geemap to do batch conversion. So I also have another video show you how to do that. So you are welcome to check out the YouTube channel to learn how to do this. Next one, you can search and import datasets from the Earth Engine data catalog. So earlier I showed you that the Earth Engine has a huge data catalog, more than 30 petabytes. So if you use geemap, you will see in here, you don't need to write any source code. You just create the interactive map using 2 lines of code, and then you can click the button here to display the source dialog. And then all you need to just enter the keywords you want to search, and then just hit import. And then you will create a new cell here beneath the map, and then you just hit run, and then you will show the data. So you don't need to download any data. So this is very, very powerful, that very easy, without really writing many lines of code. You can get the data, and then you can use it to do data processing. Also, you can search the API documentation. So there's just thousands of functions available for the Earth Engine Python API. So there's no way that you can remember every detail. So you can use the geemap package actually to search the API documentation. You can also import dataset from your Earth Engine account, your personal account, so that you don't have to go back to the JavaScript code editor to look for the dataset. So it provides you an easy way to access your datasets. And also, since this is for geospatial analysis, so most of the time you are trying to produce some products. So at the end, for example, if you do lane use and lane cover classification, you might want to display a legend. So basically to indicate what each color represents. So in the package, I provide you an easy way that you can use some built-in legend. You can also customize. So you can also copy the color code from the Earth Engine official documentation, and then just paste, and then you can convert that one to a legend like this. So very simple and easy to do in geemap. You can also add some base map from the internet. So for example, XYZ and WMS type services. So this one is not available in the Google's Engine JavaScript API. So you have a lot more dataset that you can utilize from the internet. You don't have to download anything. Also, we provide the split panel map. So this one is built upon the ipyleaflet split panel. So you will see in here, we only need 1 line of code. You can create something like this. So this is just a demonstration. You can load any dataset you want onto the map, and then left and right, and then you can use the slider to compare. This is especially useful, for example, if you want to publish dataset to the news outlet or social media. People would love this because you can compare, especially if you have some natural disasters. People want to see what's before and after, and this is a quick way people can visualize the differences of the changes. You can also use the inspector to inspect data values. Different from like traditional map application, you can only see the JPEG images, but you cannot really get the original data. So in here, we are using Earth Engine data. Everything is like in the raw data set. You can still get the pixel values out of the imagery. So you can load the dataset and then just enable the inspector. Then you just hit your mouse on the map, and then you will, based on the coordinates, it will extract all the pixel values behind the dataset, and then to display the values to you. So very simple and straightforward. Similar, this one is similar to the JavaScript API. So everything you can do in JavaScript API, right now, most of those are also available in the geemap package through the Earth Engine Python API. And also you can do interactive plotting. Earlier I mentioned that one of the key dependencies is bqplot. So this is use the bqplot, and you can load the dataset. For example, Lancet data have 7 spectral bands. You can also load multi hyperspectral data has hundreds of bands, and then you can click your mouse and you can extract the values and then display. You can do all kind of plotting. You can also export the values if you want. So for this animation shows you can just click your mouse. Sometimes if you want to, for example, you want to create some training data, you can use this way. So you just load the dataset, click the mouse, and then click. You will be able to directly export that one, all the pixel values as a CSV, and then you can do, for example, further processing, or you can create more plots using other software packages if you want. So this one here shows you how you can similar to the earlier the split panel map, but I preloaded all the dataset. For example, the common one, lens set, and also the NAP imagery 1 meter resolution. So you don't have to create those image collection by yourself. If you want to visualize the changes at any location on Earth surface, you can use this app, just one line of code, then you can create something like this and to visualize changes. Also, if you're doing geospatial analysis, most likely you might want to use some data from your local computer. So for example, vector dataset shape files. If you use JavaScript API, you have to upload the dataset to your account. So in here, in the geemap Python package, I provide you a way for you to load the dataset and directly convert to Earth Engine object. So in that way, you don't have to upload data to your account. It can save you some time. Similarly, I also use a xarray leaflet package to low raster dataset stored on your local computer. So this example shows you here how easy it is to load local raster. So in this way, you can utilize dataset from the Google Earth Engine public data catalog. You can also utilize datasets stored on your local computer. So in this way, you can interact those datasets together. For example, you want to compare the differences. This is an easy way to do. You can also publish the interactive maps using just one line of code. So this one uses Folium package and also the data pen Python package. And then you can embed this one into social media or any website you want. And the reason for this one is sometimes after you create those excellent products, you want the public to utilize what you have done. So this is a quick way that you can allow people to use your products. Otherwise, not everyone has Earth Engine skills, or they have the Earth Engine account. They don't know how to do the coding. So this is a quick way to make your information available to the public so that everyone can go online and then look at your stuff. Lastly, I would like to show you the Earth Engine app. So this is earlier at the outlines, the slides. I show you how to create an animation like this. And so the key packages we are using here is Voilà. So Voilà is a Python package that you can turn a Jupyter notebook into a standalone web application. So basically, you don't need to worry about the source code. People can just use ipyleaflet to interact with the map and then to get the results. In here, you can try out the web app. You can click the link. Pay attention if too many people are visiting the same app, it might take some time to load. So next, I'm going to demonstrate this one, how you can use this one to convert a Jupyter notebook into a web application. So in here, you are welcome to host your web application on your cloud server. You can also use some free service like Heroku or Ngrok. And I'm going to show you here how I did it. So as you can see, when you create the web app, this is the Jupyter notebook. So once you click the link, you will be basically execute the Jupyter notebook and then collect all the results and then display this one here to you. So this is what it looks like. I can also show you the source code behind. So let me unhide the source code. So if you see from the source code here, this is what it looks like to create a web app. At the beginning of the Jupyter notebook, I also show you the instructions step by step how to create this one and how to deploy, so that you can anyone with internet access, they can visualize the dataset and they can do exactly what you provide them. So let me hide the source code. So in here, I'm trying to create, for example, I want to show the changes of surface water in this area. I just click here, draw a rectangle. And then from here, once you draw the rectangle, so here you can customize using different band combinations. So for example, I'm going to use this one, and you can change the title if you want. You can change the year and start year and end year. You can also change the color for the text we are going to add to the animation. So once you are done with those parameters, just hit submit. And it might take couple seconds, up to 1 minute to for Earth Engine to collect the data and then do some processing, mosaic the data, and then to give you the animation. And then after that, I use some functions to add text automatically to the map. Okay, so now we have the map. I have the animation. So if you can see here, you can zoom in and you can zoom out, and you can draw a rectangle on any location around the globe to create animation like this. So for example, I can go back to here and to show you, for example, if you want to look at the urban expansion in Las Vegas, we can draw a rectangle like this. And again, you can change the combination like this. You can change the color if you want, and then hit run. Okay, so now we have the animation for showing the urban expansion in Las Vegas. So as you can see, it is very easy to do. No coding required. Draw a rectangle and then set the parameters. You're done. So you can get this one and then you can post on social media. Lastly, I would like to provide some additional resources for geemap. If you want more background on Earth Engine with Jupyter, you can watch the two conference presentations by Tyler at SciPy 2014 and JupyterCon 2018. We will also welcome your contribution to the geemap package. You can contribute in a number of ways. You are welcome to submit official requests or a pull request on the GitHub repo. You can also add more Jupyter notebook examples to the repo with already 360 notebook examples. And you can also help maintain the Earth Engine and geemap Docker image. If you want more live discussion, you can join the geemap Slack channel. Lastly, you are welcome to leave comments on the geemap YouTube tutorials. Okay, that's all for our presentation. Thank you very much for your attention. Take care. Bye-bye.
Thank you.